Hi everyone. Today we'll be talking about one of the features of Amazon FreeRTOS, the over-the-air updates, or sometimes we call it OTA. My name is Richard, and I'll give you a quick introduction of the OTA using Amazon FreeRTOS, followed by a demo on how to do an OTA on the development kit from our partner, Texas Instruments CC3220SF Launch XL. After the demo, then my colleague will be handling any questions that you might have. So let's do a quick introduction of the Amazon FreeRTOS. There are lots of microcontrollers used in the edge devices that requires secure connectivity, and because they have less power and less memory, well, in memory we're talking about kilobytes, not megabyte or let alone gigabyte. It's actually very hard to get them securely connected to the cloud. If you are an embedded software developer, there are a lot of things you have to figure out. Now, let's start with, we work with the chips that you choose. We have all the necessary functionalities, or if not, how to expand it. Now, even you have all these answers, where will you get the kernel code? And where will you get the additional functionality if needed? And most of the time, you don't even know how to start. So we wanted to find a way to help customers with these types of low power devices. Therefore, I'm proud to present Amazon FreeRTOS, an operating system that make it easier for devices to use the cloud. Amazon FreeRTOS is an IoT connected operating system for microcontroller-based edge devices. To get FreeRTOS for your devices, you just go to the Amazon FreeRTOS console to download Amazon FreeRTOS for your chipset. We already have a range of supported microcontrollers from companies like Texas Instruments, NXP Semiconductors, ST Microelectronics, Microchip, and Expressive, who have chipsets that are listed in the console. It comes with a sample code to get you started quickly with the cloud to let your devices subscribe to a topic, receive messages, and act on them. Amazon FreeRTOS is based on the FreeRTOS kernel, the market-leading real-time operating system for microcontrollers. And we are very honored that Richard Berry, who invented FreeRTOS 15 years ago, has joined AWS as the principal engineer working on Amazon FreeRTOS itself. So Amazon FreeRTOS extends the FreeRTOS kernel with software libraries that make it easy to securely connect your small, low-power devices to a more powerful edge devices and gateways running AWS Greengrass or to AWS cloud services like AWS IoT Core. It provides everything you need to easily program connected microcontroller-based devices, collect data from them to send to AWS IoT for analysis and action, and scale IoT applications across millions of devices. Amazon FreeRTOS helps keep edge devices secure with security credentials and key management, and it also keeps your data secure with transport layer encryption. And one of the common use cases in keeping the edge devices secure is to make sure the devices are updated with any security patches or firmware. So I'm excited to share with you that Amazon FreeRTOS has recently made the over-the-air updates OTA feature generally available on August of 2018, which is a fully integrated firmware update service for Amazon FreeRTOS with integrated code signing. Over-the-air firmware updates. The most important properties of the over-the-air updates mechanism with FreeRTOS are security. Now, updates has to be signed by an integrated code signer, streamed to the device across a TLS protected connection. And then the updates has to be verified on the target device in order to guard against corrupted or unauthorized or fraudulent updates. Next important properties is the fault tolerance. In order to guard against failed updates that can result in a useless brick device, the update process is resilient and able to handle partial updates from taking effect, leaving the device in an unoperable state. Third attribute is the scalability. Device fleets often contain thousands or millions of devices and can be divided into groups for updating purposes. All this can be done by using AWS IoT device management. And the last important properties is the frugality. Now, microcontroller, as we mentioned, have limited amounts of RAM. We're talking about kilobytes, right? And also limited computer power. Now, Amazon FreeRTOS makes the most of these scarce resources by using only a single TLS connection for updates and any other AWS IoT core communications, and by using the lightweight MQTT protocol. Each of device that runs on the FreeRTOS must include the OTA updates library. This library contains an agent that listens for an update job and supervises the update process scheduled in the AWS IoT core. Now let's look at the typical workflow for an over-the-air update. With the devices released in the field, developers back in the development center can carry on with new features or any security fixes. Once the security fixes has been included in a new firmware image, it will be uploaded to the AWS and to be signed. And then the OTA update job will be scheduled. Once a job is scheduled, AWS IoT core will send out an update notification to the devices selected to be updated. At the device, the moment the agents received an update message, the over-the-air update agents will start streaming the image from AWS over the MQTT in chunks and starts writing the image in the flash of the device. Once the image has been downloaded completely, the agent will verify the signature and notify the FreeRTOS application of the new image so that the application will proceed to replace with the new image. At the last stage of the over-the-air updates is the reboot with the new flash. Once the application on the device reboots, the bootstrap will verify the image again. And once verification successful, the OTA agent will check for the versions to make sure it is the latest before handing over the control to the application for self-test. And only if the self-test passes, the new image will be committed as a new runtime image. The OTA agent will then proceed to update the AWS with the status as completed. Now let's revisit the overview of the over-the-air updates. There are a few stages of verifications as you noticed. Therefore, there will not be any partial updates, but all or none updates to ensure the devices in the field is not bricked. With the overview, let's walk through what will be the demonstration includes. In order for a device to receive the over-the-air updates, first, the device needs to be registered with the AWS IoT core. You need to create the thing policies and to download the certificates that tie to the policy. Next, we need an Amazon FreeRTOS example applications. In this case, I'll be using the example application for the Texas Instrument processors for the demo. The example applications needs the Wi-Fi settings as well as the certification for the thing that registered with AWS IoT core. I will skip these two steps in my demo because I have registered and downloaded the certificates for the thing and configure the Wi-Fi and the certificates in the codes. I'll proceed to the next step in my demo. Once we have the demo applications with the Wi-Fi configured, we will burn this firmware into the device itself. This firmware will have the OTA agents running and listen to the AWS IoT core for any OTA messages. In the demo, I will be also using the IDE or Integrated Development Environment from Texas Instruments, which is called the Code Composer Studio. Once we have the image running on the board, I'll proceed to update the image, change the version number, build the image, and lastly, I'm going to upload the new image into the S3 bucket, and then I will schedule an OTA job. This is a hardware that I will be using, the development kit from the Texas Instruments, and I'll proceed with the demo. This is the integrated development environment from the Texas Instrument. These are the codes that have been downloaded. And as you can see now, the board is running with the version 0.9.6. I'm going to show you where you can download. When you log in to an AWS console in the IoT core, you can find the FreeRTOS device in the software. Here you can configure the softwares that you want to download. And as mentioned, we have predefined the FreeRTOS for the hardware devices that we are working with. In this case, we'll choose the IoT for the Texas Instrument. and I'm going to customize it. Here you can see that this is a hardware platform that it has been predefined for, and by default, it comes with a MQTT connectivity library. Now, we need another library, which is the OTA. So here, I'm going to choose the OTA updates. And we can choose which is the default runtime. By default, it will give you the hello world, which do the MQTT published to the AWS IoT core. But in this case, I'm going to use the OTA as the main library. Once that's done, I'm going to create and download. And here you can save the file as in your local folder. And once you extract it and import into the IDE, you can see this hierarchy. Here you have to change some of the credentials, such as the security file, the certificates file itself, and the Wi-Fi password. Okay. The endpoint, the thing name, and the Wi-Fi credential. So once that's done, you will program into the device, and then with the console, you can see the runtime. Remember, we selected the main runtime. This is a MQTT Hello World, the runtime, as well as the OTA demo. And for our case, we are going to use the OTA as the main runtime. All right. So what I'm going to do is I'm going to change this version to 0.9.7. And then I'm going to build the project. The build successful. Next, I'm going to upload the binaries into my S3 bucket. All right. Now I have my new image. Next, I'm going to schedule an OTA job. When we want to schedule a job, we can choose the devices. Remember, we might have a lot of devices in the field. So it's recommended that you use a thing group to group your devices. In this case, I have one device which group under Amazon FreeRTOS OTA. Selected the thing group. I'll move on to the next step. Here you're given the options to sign, getting the AWS to sign the image for you, or you can run the previously signed firmware image, or you can pre-sign and upload to the AWS and uses the OTA to push your custom signed image. For my demo, I'm going to use the AWS to sign the firmware for me. So I pre-created the code signing, which is using a device and a certificate. I'm going to select the image that I just uploaded, which is this guy, and this image. And for specific devices, the firmware path has to be specific and depends on the hardware that you are using. And I have pre-created the IAM role that has S3 read permissions as well as the signer's permission. Once that's done, I'm going to give the job ID. So I'll call it OTA 0.9.7. So making sure it's 97. Yes, there you go. And I'm going to create it. Oh, I've created 097. Let me create another one. Well, in this demo, I included some of the troubleshooting guide as well. So you can see because of the S3 permissions, so I'm going to find out what went wrong, which is very common in such a way that your IAM permissions might not have the necessary permissions. Now let's look at the permissions that we have for the OTA. Let's check out the S3. Yep. So here you can see I don't have the permissions to the folder. So what I'm going to do is I'm going to add this bucket into the policy. Sorry, my bad. There's a typo here. All right. Now, with the IAM fixed, I'm going to create another ID, which is 97C. Now the job is created. Let's go to the console and find out. Now we can see, let me maximize it. The device received a message and downloading through the same MQTT channel. And it has done the reboot. Now we verify the image and move on to 0.9.7. And if you go back to the progress, it shows that one device has been succeeded here. Right. So this is the demo and the walkthrough of the whole OTA. All right. With that demo, thank you very much for your time. And now we are open for questions. Thank you.